Chemical equations. There's a lot of different things I have to cover in this video, just regarding chemical equations in general, but I'm going to start with balancing because that's probably the simplest idea. Okay, so Brinkelhoff are what we call diatomics. And diatomics means that when you're writing them in a chemical equation, you always write them with a 2. So if you ever have, say, hydrogen by itself, if you're writing in an equation, you'll always write it as H2. You can't just have the chemical H1, or element. Now this is an example of a simple equation to balance. So OF2 produces O2 plus F2, produces oxygen and fluorine. Now note that since oxygen and fluorine are by themselves and they are a Brinkelhoff, we have to make them a diatomic, so O2F2. So the way we start our balancing the equation is first see that the same atoms are definitely on every side, so we know that we have the same type of atom. Now take each atom and write it out. Now next to each atom, write the number of that atom that is on the certain side. So over here I have 2 fluorines, so 2. And I have 1 oxygen, so 1. While over here, I have 2 oxygens and 2 fluorines. So I'll just leave it as that. Now to balance this, I need to make it so that there's the same number of oxygen and same number of fluorine on either side. So the easy way to do that is we add what's called a constant in front of this number. So I added the 2 in front of this number, so that 2 gets distributed to every number here. So now we have 2 O's and 4 F's. 4 F's. So that means over here, all we need to do is get 4 F's. Since F is a thing by itself, or a product by itself, because these are the products, these are reactants. So since F is a product by itself, I can add a constant to it by itself. So 2. Now I have 4 F's over here, so 4. Now that I have the same number of F's and same number of O's, I have the balanced equation. So the balanced equation for oxygen fluoride, oxygen difluoride producing oxygen plus fluoride would be 2OF2 produces O2 plus 2F2. So this equation is a slight bit harder. So we have zinc plus hydrochloric acid produces zinc chloride, which zinc is a +2 ion, so there's always going to be 2. And hydrogen, which hydrogen is a Brinkelhoff, so it'll always be by itself. So to balance this, it's actually rather easy. We just put a 2 in front of the HCl, and the 2 can distribute, and then we get 2 H's and 2 Cl's. So Zn is 1, H is 2, and Cl is 2. Zn is 1, Cl is 2, and H is 2. So that checks out. Now I'm moving on to types of reactions. I'm going to start with the 3 basic types of reactions and then move to the more advanced ones. So the first one is synthesis, which is rather easy because synthesis is just a metal or a nonmetal plus a metal or a nonmetal produces a compound, C. So A plus B equals C. That's the simple synthesis reaction. So an example of this would be H2 plus O2 produces H2O. That's not balanced. 2H2 plus O2 produces 2H2O. That's an example of synthesis because we have 2 separate compounds combining to form one major compound. Now decomposition is just the reverse of synthesis, where we have C produces A plus B. So decomposition would be like 2OF2 produces O2 plus 2F2. That's an example of decomposition. Combustion is a slight bit harder because combustion is a carbon-hydrogen compound mix. So it always has to be a carbon-hydrogen compound, such as methane, which is CH4, plus oxygen produces a gas, such as carbon dioxide, CO2, and water. Now, if there's not enough oxygen in the reaction, what will happen is it'll start to form carbon monoxide. And a giveaway of a combustion reaction would be a blue flame, but if it's producing carbon monoxide, then it's a yellow flame. So yellow is carbon monoxide, but blue is carbon dioxide. And those are the simple equations. Okay, so this is a slightly more advanced one called single displacement. So the way single displacement works is we have A plus BC produces AC plus B. So basically what happens is the A and the B swap. But this only works if A is a metal and B is a metal, or A is a nonmetal and B is a nonmetal. But they both have to be the same. And also coming into equation in this is this. This is our strength chart of metals. The only way this equation works is if A is stronger than B. So the way the strength chart works is it starts for metals at lithium. Then it goes to potassium, calcium, sodium, magnesium, aluminum, zinc, iron, tin, lead, copper, silver, platinum, gold. Gold is the least strong, and the way you can remember this is that the more expensive the metals get, the less strength they have. So, take for example salt, which is sodium. You can remember that salt's really cheap, so it's going to be really strong. Or gold is extremely expensive, as are platinum and silver, so they're going to be really weak. This is also true because jewelry can hold gems without getting corroded because the metals are more weak and won't react with the gems. For nonmetals, all you have to do is go down the period of halogens, starting with fluorine, then chlorine, then bromine, then iodine, with fluorine being the strongest and iodine being the weakest. So the only way a reaction like this would work is if A is F2 because it's a Brinkelhoff, plus Cl, I don't know, hydroxide. Oh, that doesn't work. Never mind. Just remember that the A and the A is stronger than the B, and they both have to be a metal or a nonmetal. So, for metals, if A is sodium and B is lithium, the reaction can't work and there's no reaction. But if it's sodium and magnesium, then the reaction will happen and the A and B will switch. This is the slightly more advanced version of single displacement called double displacement / replacement. Those words are interchangeable. You can call it dis or replacement. So the way that double displacement works is you have AB plus CD, where A is a metal and C is a metal, B is a nonmetal and D is a nonmetal. So they react and they form AD and CB. So basically what happens in this reaction is the nonmetals switch with each other and just swap which metal they're at. Now, a special form of this reaction is called neutralization. And neutralization only works if this is an acid and this is a base. And what happens is this forms a binary salt, and this is water. And the reason this happens is because bases always have hydroxide and hydroxide as their nonmetal, and acids will always have hydrogen as their metal. So the hydrogen combines with the hydroxide in the CB part, and that forms water. And then the A and the D combine to form a salt, a binary salt. And that's basically. Okay, so this is a simple neutralization reaction. What we have is aluminum hydroxide, so aluminum's plus 3, hydroxide's minus 1, so we have 3 hydroxides, so distribute the 3. Plus sulfuric acid, which is H2SO4, forms, and since it's a neutralization equation, we can know that one of the products will always be H2O, because the H's and the OH's are going to combine, which means that Al and SO4 are going to combine. So the way to combine Al and SO4 is Al is 3 plus, and SO4 is 2 minus. So that means that we need 2 and 3. So we have AlOH3 plus H2SO4 produces Al2 parentheses SO4 3. So now we have to balance this equation. So over here we have 1 aluminum. We have 3 plus 4 is 7 oxygens. We have 3 plus 2 is 5 hydrogens. And we have 1s, so S is 1. Over here we have AL is 2. We have 3 S's. We have 13 O's and 2 hydrogens. So what we need to do over here to balance the equation is find what goes into these numbers that would make them balance. So we already know that AL, there's 2 over here and 1 over here. So the easiest thing to start would be to put a 2 in front of this. So now we have 2 aluminums, so we can change that. So those 2 check out. Now this 2 will also distribute over here, so now there's 2 times 3 hydroxides. So that means that there's 6 oxygens and 6 hydrogens now, plus the numbers that were already here. So now we have 10 oxygen over here, and 8 hydrogen. So now we move on to the other number that occurs the least, which is S. We have 3 S's over here, so that means we need to put a 3 out here. So we can add 4 to the hydrogens and get 12. And we can add 8 to the oxygens and get 18. So our easiest step, and we have 3 sulfur. So our easiest step now is going to be finding out how to balance it over here. So we need to multiply by 6 to get the right number of hydrogen. So 6 H2O. And that also adds 5 oxygen. So we have 18 oxygen and 6 hydrogen. And that's how you balance it. So this week, as an added bonus clip, I'm going to explain Act 1 of Macbeth for you. So first we have the 3 witches. The 3 witches are all like, fair is foul and foul is fair. And this is a hipster witch, because it's wearing the hat sideways and has skinny jeans. And then in scene 2, we got the captain explaining to the king what happened at the battle, and he's like, yo dog, the Thane of Cawdor betrayed you, but Macbeth and Banquo are tight. And then the king's like, Macbeth will be Thane of Cawdor, and I'm a magical fairy princess. And then Macbeth is killing a Norwegian, and he's like, Allah Akbar. Then in scene 3, we have Macbeth and Banquo meeting the witches who tell their fortunes, and the witches tell Macbeth that he's going to be a king, but they tell Banquo that he's going to have sons that will be kings. And Banquo's all like, those guys have beards, they can't be women, so they can't be witches. And the hipster witch is like, yo, I'm too cool for hats. Then in scene 4, we got the Thane of Cawdor being executed, and he's like, I'm sorry, I betrayed you. And the executioner's like, too bad, and kills him. And the king's just like, I like puppies. Then in scene 5, we have Lady Macbeth, who wants to be a man so she can be vengeful, and she's also very power-hungry. In scene 6, we have the king coming to Macbeth's house, and Lady Macbeth's like, I'm totally not going to kill you, dude. And the king's like, my best friend is imaginary. And Banquo's like, seems legit. Then in scene 7, we have Macbeth having second thoughts about killing the king. And Lady Macbeth's like, bitch, please, you're gonna kill the king. And that's how Act 1 ends. So, hope you enjoyed the video. If you have any questions, hit me up on Twitter. My Twitter will be in the description, and you have to send your questions at #ChemistryGod. If you don't add that hashtag, I will not reply to your questions. Or just send me a question on Facebook, which would actually be easier because you don't have to add the hashtag. But seriously, if you don't add the hashtag ChemistryGod, I'm not answering your question. I'm sorry. Alright. Thanks for watching.